All right. Hey, so it is great to be back. It's this is lecture 1 for bioenergy. We're spring 2016, and what I want to do just in this first lecture is go through the syllabus, go through some intros, and just a few little other background things. So I also want to let everybody know, first off, that this is a course that was developed by Brian Kearns back when the program first started in 2007. It's a 200 level course. If you're taking this, you've already taken NRGY 102, one of the chapters. I believe it's chapter 4, maybe 5 from the 102 text talks about bioenergy. So we got to dip into it a little bit, some exposure, but that's what this course is all about for bioenergy. As I was just mentioning, we were just talking that Americans do have a hard time wrapping their heads around the rate at which we consume energy. I think on a per capita basis, we're not at the top. There are a few other countries that consume more per capita. I think the UAE might be one of them, maybe Dubai. On the other hand, they don't have nearly as many people. So when you sort of multiply the number of people in the U.S. times the energy per capita, we're one of the larger consumers. And a lot of other countries are starting to catch up for comfort reasons, manufacturing industry, et cetera, all takes it. But bioenergy has, many dimensions. You can even look back even to where all of our coal and fossil fuels come from, and essentially that was bioenergy. Those carbon bonds were put there by a biological entity, photosystem 1, and so it's just a matter of whether it's new biomass or old biomass. Okay, and let me, I'm going to go ahead and just look at the introductions. I see I've got 6 unread posts. I think that'll be a nice place to start. Brian Kearns, bless his heart, made this introduction before we got the news that we're cutting back on adjuncts. So let me just take a look at that. So it says, I know most of your web classes ask for similar introductions. Please forgive the repetitiveness. It lets me get a sense about the class. So kindly post a brief introduction about yourself, things to include hometown, etc., etc. So Kearns has lived here since 2002. He did work with Paul Williamson. Paul Williamson is no longer the dean. He actually brought the hydrogen fueling station to Missoula, along with, and I'll make that a little bit bigger so you guys can see all that, brought the hydrogen fueling station to Missoula, got the wind turbine set up, got the solar panel set up. As you know, we just took all that infrastructure down because that's where the new Missoula College building is. But if I'm not mistaken, Paul Williamson just came out with a new textbook for renewable energy. I don't have a copy of it, but he's just a dynamo, just really hands-on guy. Every time I see him, he's always working hard over keeping that hydrogen fueling station working. The program is web-based, and this is the 21st century. If we could do everything face-to-face, it would be great. But being in Montana, small town, long streets, you got to reach the folks that are out there, not on campus. We also have some really great alumni in energy technology. One of them works for the Belgian embassy in Washington, D.C., Michel Wallamack. So he came into it with a master's in economics, but didn't know a kilowatt hour from a megawatt, et cetera, and used this to his benefit. So when people ask me, what do your graduates do? Well, I said, some of them run the economy of Belgium, for God's sake. So it's not a one-size-fits-all. Brian still calls it alternative energy. I tend to use the word sustainable or renewable. I think it's a little more mainstream. The 10-kilowatt wind turbine is going to be installed at Kettle House Brewing in their new facility up the Blackfoot. Excited to see that. And Brian is, putting his theory into practice by working as the energy manager at the university. So he does a great job like that. The portable bioenergy generator we currently have, and what I really want to do this spring is get the class down the Bitterroot. I've got a fantastic colleague down the Bitterroot. He's got a 55,000 square foot greenhouse.
Nice.
And the idea with the biomass generator is you take the biomass, which is going to either decay or burn at some point. That's what happens to all carbon bonds eventually. But put that biomass to use to make carbon dioxide for the greenhouse, also electricity, of course, and heat. So now you can sort of grow year-round, extend your growing season. And what we'd also really like to do is take the firefighting problem that we have in the state, go ahead and do some forest thinning and use that for energy rather than having a $2 billion a year fire budget and all that mess.
This is the one that sits on a tractor trailer, right?
Yeah, it's the Biomax. Let me pull up a big...
Talked to Brian a bunch about this in the alternative fuels class.
Yeah. Oops. Biomax trailer. 25 kilowatt.
Yeah, that was going to be my next question.
And you got an image. Yeah, here's a shot of it right here.
Nice.
I think this actually might be ours,
Cool.
if I'm not mistaken. So anyway, this one's sitting down in the Bitterroot Valley right now, and really hope to get everyone down there and get it up and running.
Is it running right now?
It's not running right now. It needs a software upgrade, and really just like any technology, just some hands-on, just get her up and running. So,
Cool.
Yeah. So that's that.
And that's the university's rig, right?
Yep.
Cool.
Yep. We own it. Yeah. All 25 kilowatts of it.
Mm-hmm. That's good size.
3 aquatic turtles, border collie, stray cat. if you ever on, and I can't remember the name of his street, I think it might be Evans here in town.
Mm-hmm.
Hop over and you can see the neat fleet of vehicles that Brian has
That's his spot on Evans?
Yeah.
Cool.
That's his. Yeah.
Oh, yeah, I knew he had a thing in a Land Cruiser that he...
Yeah, no, it's fun. I see him driving the thing around. I'm like, Brian, what's that smell coming out of the back? He's like, oh, it's that would be VOCs, unburned hydrocarbons, you know. But,
Run a little rich.
and I don't know. Yeah. That's fun. Okay, so Sean Doty Sean has been. I think he's going to get his degree this spring. He's also environmental studies student. He helped us build our micro hydro last summer during the program, practicum, which was a blast. And it sounds like he is now in Spokane. I heard he just had a little, unfortunately, kayaking accident. I think he's fine. I had one myself, so I know what that is like, man. It can be scary. Yeah, it really can. It's for real. So, but he's back with us and I think recovering pretty well. Joe, so he took Brian's alternative course, maybe a little bit of a review. Okay, Minneapolis. I also know Joe's been a pretty active cyclist here in Missoula too. Rock climbing too. Great. Okay, here's me. Do my best semester, guys. I'll try. I'll do it. And seriously, you know, and unfortunately, and I wish education did not come down to money the way it does, but unfortunately it does. And I do think we have some great community support. And so right now I'm just going to reach out to some of the folks that I know who've actually done pretty well in renewable energy and see if they can't give back. I even know that we've got some alumni who can probably help as well. Yeah. Nick Krueger, great to see him back too. He was in a pretty cool project, I guess it was 2012 or 2013, with another one of our illustrious alums, Mark Broston. They recovered about $3,000 worth of precious metals from some computer towers, so glad to have Nick back. I think he's working on finishing up too.
Nice.
Let's see. I would say being a neat freak is a bit unusual. It's a weird niche. I can't focus when things are out of order. Okay, we'll remember. Yeah, welcome to my office, Nick. Come on in.
Pretty good.
Yeah, well, you can see the floor. You can see the floor. The desk, maybe not so much, but okay. So that's Nick to Sean. Okay, and here's Cody. Cody's been in the program for a while. He was a child of 9. Okay, that's a little uncommon this day and age. Enjoys the outdoors. Class, super. Well, we all hope to do better in our grades, Cody. Don't sweat that, man. It's fine. Oh, right. Okay. Mark Hansen. This is a great course. We got some fantastic guys in here. Moved to Missoula in '98. Learned some more about using food waste as energy. We will definitely talk about that. I was just, as I said, I was just in Browning this morning and had a conversation with a pretty high-end guy that is, if you want, look up this professor. He is a dynamo. If I can read his handwriting, Tony Hartshorn. Tony Hartshorn is a soil scientist at in Bozeman. So I don't know if you guys are thinking about carrying on with a 4-year degree. He seems like a really sharp investigator. He does soil science. So as soon as I read this, turning food waste into energy. I mentioned to Tony that I'm a pretty intense composter at my house. He said, well, composting can produce a lot of greenhouse gases. I said, well, I know. If they go anaerobic, you can make methane there. So I guess what I would love to do, and I'm hoping we have the opportunity to do this with Brian Jackson at Bitterroot Valley Greens, also Mark Laparco, and I'm hoping too, Jason, you continue with that composting system. We'll see. Yeah, we got to get Davis back in here. We'll see what we can do. But so it's got to be done right. And what I would love to be able to do is composting in a carbon negative sense. So if you're making more CO2 from your compost than background, so if your compost pile is sitting there above 400 ppm, what do you do with that? Well, send that gas out into a greenhouse that's actually doing active photosynthesis.
I recently read a lot about doing 365-day greenhouses with compost providing a good portion of your thermal return to keep it going.
Yeah,
large enough greenhouse, that'd be a good idea.
Yeah, I guess my thoughts on the 365 greenhouse in the Missoula Valley, I think that's going to be a challenge. Just getting enough sunlight in. And if you're taking NRG or ETEC 214, you might get creative and say, well, we'll run the lights. Where does that come from? Well, maybe you're making electricity from the bioenergy. Maybe you're actually banking electricity. Maybe you're sending some of your rain runoff to the Gordon Butte pump storage facility that's going in. But there's always some way to get away from the carbon. It's not easy, but hopefully by now in your energy tech career you can see there's always some way to hide those CO2 molecules.
Better percentage here and there.
Yeah, right. Okay, well that's a good set of intros.
Legalize marijuana?
Well, believe it or not, I've had a lot of folks call me from the state of Montana legislative level and say we would really like to legalize the hemp industry in the state.
Yeah.
And it's a fantastic fiber.
Yeah.
And it can be grown for industrial uses rather than recreational uses.
Yeah.
That said, with marijuana being legal in a couple states, they've got waste.
Yeah.
They've got waste fiber, and why not put that waste to some kind of use? So there's bioenergy there too.
Absolutely.
Yeah.
It's high on the cellulosic material, but it's good fiber.
Hempcrete.
Can you add me to the Moodle shell for bioenergy?
Oh, are you not in here yet,
I
David?
don't think I am.
Oh, really? Oh, you know what? That could be because you guys are in Section 1
Okay.
instead of Section 50. I'll have the Online guys just merge you right in. Okay, yeah, thanks for asking. Thanks for asking. Okay, so let's get back. I like the way Kern set this thing up. He's got the finals at the top. You probably can't see that in your student view, and he's got the intros at the bottom. So I'm just going to go right down through this thing and see.
Just like his alternative.
Let's just bang right through it. And what Brian told me is like this course will run itself. It's not the professor is sort of a sideshow. maybe, but let's just orient ourselves.
In this format, it's just like his fuels class, and in which case that's totally the case.
Yeah.
It's got a really logical flow to it.
Yeah. Well, and this is pretty strong words. Brian Kern said, call the dean, call the provost, keep energy tech alive.
I've got a letter drafted, and I'm going to do one of them open. And
Yeah,
ask the guys to sign it.
it has not been an easy row to hoe here in town, but anyway, I do appreciate everyone's support. I really do.
Yeah, I'll sign it.
Yeah, because there's a lot of people that have the same feelings.
Yeah.
And I think that, we have a little bit of leverage, we're paying to be here.
Mm-hmm. Okay. I'm just going to I'm not going to read this word for word. I just want to say we've all looked at it. Feel free to comment on the course. Obviously, we'll have a weekly forum. There'll be something there to chime in on. That's the syllabus. We'll do that in a second. Now, I'm usually fairly lenient with this, but it says once the due date is passed, it will not be an opportunity to make it up. So that's really because we're all busy. And, this semester I am super duper extra busy, and I'm not going to really be able to afford to do a hell of a lot of, backtracking and one-off grading. Syllabus contains its calendar schedule with all assignments due, fairly predictable. Discussions are due Wednesday. Homework is due on Fridays, and quizzes are on Sundays. So that's pretty simple. Yeah. First discussion is due tomorrow,
yesterday.
I guess he's got, I don't know why, he's got the old, I guess he's got the old date in there. I guess I'd have to go back and look to see whether that's a week 1 or a week 2 thing, but I'm not going to get too crazy with that because I'm starting from behind on this too, so don't sweat that one a whole heck of a lot.
It's good, because right now I can't.
I know.
I'm already behind.
Yeah. So hopefully what we've been able to do with 102 is actually prepare you with some of the chemistry, the math, and the physics. There's no way around it. Also, I want to let you know that Tim Chester is available. Tim's gone through this course with flying colors, and is there to help too. So let me file, new, save, and that's just Tim of the. I'm getting worse at spelling all the time. Did I spell Timothy right? Montana. That's the only way to spell it, right? Timothy.
Just spelling right nowadays.
Yeah. Right. I know that there's a lot of new age spelling going on out there, but Tim Chester, I think I added him to the course too, and he's a great resource and right down the hall if you're stuck on math. Okay. Please contact me sooner. Yeah, and so this says I'm going to have to update this too. I'm not going to be around that late on Thursdays. I think we will have it on a Thursday. It could be that I'm doing 102 from 3 to 4:30, and maybe we do this class from 4:30 to 6. Does that work?
Can I get back to you on 4:30 to 6?
Yeah.
I just need to check one thing.
Okay, we could also run it on a Tuesday, but I'll be on campus Tuesday, Wednesday, Thursday.
Okay.
Is the deal.
I mean, I'd like to say that'll work for me, but I gotta check.
And really, if you are the only two face-to-face guys, we'll just work with it.
Let's
Okay.
talk between the three of us
Yeah.
and figure out one that works.
Yeah.
Okay.
Yeah. Oh, and for me, you can call me Brad. And in fact, yeah, I don't like being called Mr. Layton. You can call me Professor. I do have that title, and you can call me Dr. Layton if you want, because I have that title as well. Because I am a PhD. So, okay. I like that. I like the fact that he's got humans there about to explode into some bioenergy. Week 1 announcement. Let's take a look at the syllabus. I want to see how we're doing on time here. Yeah, we got a little more time for 10 more minutes. 3 credits. Physical nature of various biomass resources. Feedstocks, useful products. it is worth notice, I don't know if this is going to be on any tests or not, the sun does provide energy at a rate 10,000 times greater than humans use it. That's one number just to keep in the back of your head. It's also worth noting that, I think this is right, I think we'll look at the Shramsky paper, I think humans consume about 1/4 of the biomass that the biosphere produces every year. So if you just looked at, how much new biomass is generated each year, say, I'm going to make, this number is obviously not right, but let's just say the biosphere makes 4 tons of biomass, it's probably closer to, 40 billion tons. We use 1/4 of it. A full quarter. So that's how quickly it's turning over. If you go back, to Roman times, it's going to be much, much less. If you go back to our hunter-gatherer ways, way less. So we are churning through biomass at a rate about 25% at which nature makes it, and that's from Shramsky 2015.
Does that accommodate like firefighter or forest fire loss, those kinds of things, or just actually what we're using?
That's a good question. I don't know if forest loss due to firefires counts in that. Obviously you grow your corn, you harvest your corn. That's your harvest. Same thing with any agriculture. We're really harvesting that at a rate of 100%.
Right.
But then you start, you put in logging, you put in, pulling. This is, well, it could even be, it could account for fishing too. I don't know. I'd have to reread Shramsky, but it could account for any purpose-grown protein product that's actually living off the biomass that it's eating. It could account for cattle as well.
Agricultural
Yeah.
feedstocks.
So there's obviously right. So there's a lot. Yeah, right. So purpose-grown corn. There's a lot of accounting going on there, but another kind of big number to. So when he says biomass is ubiquitous, it could provide a significant share, and it's true. We could go at it at a greater rate. I think it's, but it would be a much greater portion than 25%. We would really have to start burning down forests in a big way to start replacing coal, for example. So there's your sustainability balance.
The density on coal oil is just so much higher.
Yeah. Okay, textbook. Do you guys have a copy of this book?
Not yet.
Okay,
I just got it in at the bookstore.
Okay, super.
I'm gonna price it.
Okay, there we go. There we go. Yeah. Understand the basics. You guys getting that? Okay.
Good need these copies from the $10. An awful lot better than the $75 used.
Yeah, take a look.
Amazon's awesome.
Yeah.
I save so much money. It's ridiculous.
Yeah.
I really hope to get us down there. Maybe, guys, I'm going to be in Japan, it sounds like, end of February, early March, and that might be a good opportunity to get you down at Brian Jackson's ranch down in Corvallis. Cool. So maybe we'll schedule that. In fact, I'll make a note to self on that. Okay, perfecto. Upper level required. Comprehension. Yep. Chemical. Yep. Field experience. Like I said, I think the Brian Jackson's farm is going to be perfect.
That sounds. I wanted to see that biomass generator.
Yep. And I think what we can do, and again, it just takes money. I do have a proposal into the Fed right now for $350,000, and part of it is getting that up and running. We might be able to justify some current NSF funds to put into it, and I've got my fingers crossed. But we also just put in a $30 million proposal with the Fed to see if we can't really get the biomass industry up and running in Montana. We'll see what happens. None of this is a done deal. There's a lot of politics, a lot of banking involved, but I really hope that happens. Okay. Definitions, histories. I'm not sure we're going to get to all of this in class today, but that's what we're looking at in Unit 1. Nice. Okay. And I'm just going to stop there on the syllabus. We've got 5 more minutes. I'm going to try to keep the lectures to 30-minute segments, so I'll go for another 5, and then maybe go for an additional 30. We'll just see.
There's a lot of dimensional analysis in biology classes.
Yeah, and let me just give you a quick example of that. When this is something, and again, I've been teaching engineering and energy tech for a long time now. But one thing that became very clear to me when doing a conversion problem, and let's just do something kind of simple. Earlier today, I was looking at the price of HDPE. HDPE is high-density polyethylene. Polyethylene is a very highly refined biomass. It's actually coming, so when an oil refinery cooks off its products, that oil was ancient biomass. Ethylene is, it's 2 carbons. It's 6 hydrogens, like so. So that's a single ethane molecule, methane being 1, ethane being 2. Now, if I want to make polyethylene, really all I'm doing is this, just kind of all day long.
Just put an H in.
Pretty simple, yeah. And just the H's are here. That's the, and then the longer it gets, the higher density it becomes. If the chain is shorter, it's more or less low density polyethylene. So
Gotcha.
a high density polyethylene is highly processed biomass. It's a plastic. But here's the thing on unit analysis. I was looking it up, and it was 29 cents per pound. Okay, so right now there are in this one little snapshot, you've got 3 fundamental things going on. One is, I'm just going to number them. One is just the number. I'll just use a pound sign for number. The other one in here, it's actually sort of invisible, but I'm going to point to it anyway. And that's the confusing part. Number 2 is the power of 10. We don't have one. It's just assumed that this is actually 10 to the 0. 10 to the 0 is 1, so it's 29 times 10 to the 0. And then the third part is, and I'm just going to try to point to both of these things at once. The third part are the units. In this case, it's cents per pound. And really, those are the only 3 components you're going to see: is the number, the power 10, and the units. And those, and there you can. So there's 3 ways to screw up. So think of this as the arithmetic you learned back in 1st grade. This is sort of the powers of 10 you probably learned later in elementary school. And even this is just kind of when it comes down to it, just kind of home economics when it comes down to it. But we'll build from there. So all I want to do now is just convert 29 cents per pound to dollars per ton. And let me show you how I typically do that in a expeditious manner. So I just make myself one big long division symbol, and I start out and I put in my 29 here, I put in my cents, and I put in my pounds. And I know that eventually I want to get to dollars, and so the dollars are going to be in the numerator. No surprise there. So there's dollars. And the thing I'm going to get rid of is the cents. So then I'm going to put the cents down here, and I know they're going to cancel. And all I have to do now is figure out the right number to put in with the dollar cents. So of course, as we well know, $1 equals 100 cents. And really all we're doing with this little chunk right here is multiplying by 1. And as you know, you can multiply by 1 all day long, nothing changes. Now, we're going to do the same thing with pounds to tons. And I'm just going to use a short ton, which is 2,000 pounds. There's other definitions of the ton. But so for now, I know that I want to get rid of pounds, so I'll put that here. And I want tons in the denominator. So I know that 1 ton equals 2,000 pounds. And then from there, I know I'm going to get my answer. Just erase this. No problem. So this, and again, this is super simple example, obviously, but from here, all I need to do, what I'll first do is cancel out the cents. I'll cancel out the pounds, and I know that I'm now going to be left with dollars per ton. And from there, it's really just a matter of arithmetic. So I can just pull up a calculator. Well, another thing you might do before you get too crazy with the calculator, we could even with this one. I think this is appropriate for this level, of course. We can just get rid of these 2 zeros, and really now we're just multiplying 29 by 20 is all we're going to do. And so I might be able to do that in my head. Let's see, 29 times 2, that's 40, it's 58, just shy of 60. Put another 0 after it, and I've got 580. We'll see if that's right. I did it in my head. We'll see. 580 dollars per ton. I'll double check it on the calculator. 29 times 20 equals 580. So I just converted that, and that's unit conversion.
Yep.
And there will be much larger ones, I assure you, and much more complicated problems. But that's just kind of to get you rolling. Yeah. Oh, and check your work. There it is. Check your work.
That's the important part.
Yeah. Okay.
Thanks.
So I'm gonna just save that into. I love diving in here. Now I actually get to make a new course. So here are all the energy tech courses if you ever want to see them. I mean, here's ETC 120, 213, 214. We do a little EVST 101, 101, 102, 120 on down the road. So now, there's biofuels, 2016. I'll just call this lecture 1 units. Okay, so I'll save that. Sometimes I post this, probably not. A lot of times I think if I post these notes, you didn't watch the lecture, it's confusing. What is that thing? So maybe I'll just leave it as is, and we saw it. Okay, let's take a quick break, and yeah, a little over 30, that's okay.